This presentation is about the James Webb Telescope, a telescope that was launched December 25th and is 100 times more powerful than the Hubble telescope. We'll first take a look at CNN's announcement on the 25th of its launch, and then we'll talk about the mission.
NASA got a huge Christmas gift this morning when it successfully launched its most powerful space telescope ever.
We have engine start. And liftoff.
Décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
The launch of the James Webb Telescope was more than 20 years in the making, involving thousands of scientists, multiple countries, and it will likely change the way we see the universe.
As mentioned on that news clip, the Webb telescope is one of the most sophisticated and complicated deployments that NASA has ever attempted. This giant tennis court-sized marvel will be folded up and stuffed into a capsule that is less than 18 feet in diameter. And unlike the Hubble telescope, which is in low Earth orbit, the Webb telescope will be launched to a point 1.5 million kilometers from the Earth. And as you may remember, when Hubble was launched, there were some problems with it, and they had to send the space shuttle out with a crew to help fix it. Not the case with the Webb telescope. Once it's launched, it's on a one-way mission, and everything must work correctly. So where exactly are they sending this telescope? As I mentioned in the news brief, they're sending it to Lagrange Point 2. So, what is a Lagrange point, you might ask? First of all, the points were named after Joseph Louis Lagrange, who was an Italian mathematician and astronomer who lived in the late 18th century. He calculated that when there are two celestial bodies orbiting each other, there are 5 points where there is neutral gravitational pull between those two bodies. Those 5 points are labeled as L1, L2, which is the destination of the Webb telescope, and L3, which are in line with the two celestial bodies. Then there are the positions L4 and L5, which triangulate between the two celestial bodies. Lagrange points 1, 2, and 3, while gravitationally neutral, are a bit unstable, kind of like putting a marble on top of a watermelon. Yeah, you can make it stable, but you're always going to have to adjust it a little bit to keep it from falling off. Lagrange points 4 and 5 are more stable in that they are triangulated between the two celestial bodies. That'd be more like putting a marble inside a bowl. When you try to move it out, it'll roll down to the center of the bowl again. Here is a depiction of how the Lagrange points move as the Earth orbits the Sun. The Webb telescope will be at Lagrange point 2, so it can be shadowed from both the heat and the light from the Earth and the Sun. From its launch at 4 a.m. Pacific time on the 25th of December, it will take 29 days for the Webb telescope to reach L2. During its 29-day transition from the Earth to its final destination, the Webb Observatory has 50 major deployments and 178 release mechanisms to deploy those 50 parts. They call it the 29 days on edge. Quote, every single one of the mechanisms must work. Unfolding Webb is a hands-down the most complicated spacecraft activity we've ever done, said Menzel, a Webb mission system engineer. About half an hour after liftoff, Webb deployed its solar panels and started soaking up the energy from the sun. Then the giant telescope also performed a crucial 65-minute engine burn that put it on course for L2. On day 5 after the launch, the pallet holding Webb's giant sun shield, the 5-layer structure designed to keep the infrared telescope and instruments cool, is deployed. 10 days after the launch, Webb extends its secondary mirror, which is so named because it's the second surface that deep space photons will hit on their way to the telescope's instruments. 12 to 13 days after launch, Webb's 6.5-meter primary mirror will shine, composed of 18 hexagonal segments. The mirror's two side or wings will extend and lock into place, giving the surface full size. At that point, Webb will be in its final configuration. The vast observatory will arrive at its destination slightly more than 2 weeks later, conducting another engine burn 29 days after launch to slip into orbit around L2, where a different set of ramp-up procedures will begin. Meanwhile, the Webb team will test and calibrate the telescope's 4 scientific instruments. The group aims to start regular science operations 6 months after launch. So, what do we hope to learn, and how will we use this to explore our heavens? Webb will be able to peer back in time to explore the edge of the universe as it expands. Whereas the Hubble telescope with its instruments can see back to about 1 billion years after the Big Bang, Webb telescope will be able to see the very early formation of stars just 0.3 billion years after Big Bang. In February 2017, astronomers announced their discovery of 7 Earth-sized planets orbiting around a star called TRAPPIST-1, an ultra-cool dwarf star just 40 light-years from Earth. With the instruments aboard the Webb telescope, scientists and astronomers will be able to examine those planets and determine if they have atmospheres and the chemical makeup needed to support life. It's an exciting time for astronomers, scientists, physicists, and all of us as we explore and extend our knowledge of the vast universe in which we live.